Welcome to the confidence interval and hypothesis test video. I am Bo Corkins, and this is statistics. So we want to run through some examples regarding confidence intervals and hypothesis testing, and let's just jump right in. So direct mail advertisers send solicitations, aka junk mail, to thousands of potential customers in the hopes that some will buy the company's product. The acceptance rate is usually quite low. Suppose a company wants to test a new flyer. It sends it to 1,000 people randomly selected from their mailing list. They get orders from 123 of the recipients. Estimate the percentage of people the company contacts who may buy something with 97% confidence. So this is clearly a confidence interval question, right? So our very first step is identifying, is it confidence interval or hypothesis testing? This is confidence interval because it says confidence. So we start by identifying our information. P, which is the true proportion. All right, which now we are assuming is unknown. The true proportion is an unknown value. It's something that we are trying to estimate. The sample proportion is what is observed from the data set. 123 out of the 1,000 gives us 0.123. Then we check our conditions. So there's a three-step process to confidence intervals. All right. Step one is conditions, and these conditions should be very, very similar to what we've already seen. Large enough condition, n equals 1,000. Which is greater than 30, so that one's. Then success failure condition. Now it's NP hat, NQ hat. We no longer have the true proportion, right? Because that is an unknown value. And Q hat, remember, is always just 1 minus P hat. So all conditions are met, and again, all three of these conditions have to be met to be successful. So the conditions are met. We may assume the sampling distribution of P hat is normal, with a mean equal to P, which is unknown, and standard error. Now, I could call this standard deviation. This is really semantics. Standard error, standard deviation. The difference is literally about using P hats versus like P zeros or Ps. So you could still call this standard deviation, and it's still practically the same thing. The definition is, again, semantics only. So calculate a way to find the standard error, standard deviation. Once you have all your conditions checked, then, all right, you may proceed to the calculation or mechanics step. So calculations. We have a very simple formula. Estimate plus or minus Z star times the standard error. Well, we've already got some of this. So the estimate is the 0.123. Z star we're going to need to look up, and we already found the standard error as well. So the only thing we actually have to identify in our calculation here is Z star. it's important to understand how Z-star works. So if you have 97% confidence, that means you have 97% of the area in the middle of the graph, okay? It's not to the left or to the right, it's in the middle. So in order to look this up in our Z-table, because everything in our Z-table is to the left, we need to understand what's outside. So if there's 97% in the middle, that means there's 3% on the outside, and hence 1.5% on each side. So you can look this up two ways. I can look up 1.5%, or I could look up 98.5%. Regardless, that will give me the two values. One will be negative, one will be positive, but it will be the same value. So I always think it's much easier to look up the lower value because then I don't have to add it. So I'm going to look for the closest value to 1.5%. That is 0.015. So right here, 0.015, I actually got it exactly, corresponds to negative 2.17. All right, for the Z-star value. Similarly, this would then be positive 2.17. So between negative 2.17 and positive 2.17, we capture 97% in between. Hence, the Z-star value, we call it 2.17. We typically drop the negative because it's always going to have the plus or minus, so that negative is accounted for. So you can just put in 2.17. Now, remember that 95% confidence is 1.96, right? 90 is 1.645. So we have those three values that are commonly used, but you should be able to look up any confidence level value, all right, with this method and using the Z-table. So calculate away. All right, gets us 10% to 14.5%. Last and definitely not least, conclusions, interpretation, explanation. We are 97% confident. So we are 97% confident that the true proportion of people that the company contacts that may buy something is between 10.04% and 14.55%. So again, notice what this has: confidence level, true proportion, context, and the interval. All right. So these pieces have to be in every single one of your interpretations. All right. Make sure that you have that in your interpretations for a complete interpretation of a confidence interval. All right. We will look at hypothesis testing in our next video. Thank you very much.